Good afternoon, everybody. First of all, my thanks to organizers for this opportunity, and particularly for this topic, which I consider is most relevant question a Tyre Technology should answer today. What next after low rolling resistance? This is a very pertinent question today. I hope my presentation will answer this effectively. So the topics which I would be covering in this presentation will be evolution of Tyre along with automobiles, and the Tyre challenges with electric vehicle and autonomous vehicle, and emerging Tyre requirements. And I will also highlight a bit of my company's initiatives to support our own business as well as the larger society's interest. So if I look at the evolution of automobiles and tires, most of it happened in the last 150 years, starting with external combustion engine to internal combustion engine to no combustion engine today, and little more into the future you will see a lot of driverless vehicles. Automobile industry has come a long way. And parallelly, tire industry has also evolved along with automobile industry, effectively supporting automobile industry in its journey. So if I look at the evolution of tire industry, I can effectively categorize it into three eras. The first one was the empirical era, where the expectation from the tire was to just roll into the direction in which it was pointed. The control forces were limited by the friction and the load on the tire. And in the era which followed and lasted up to 1970s, a lot of things happened in the automobile industry. The mechanism of steering, understeer, oversteer, and influence of the suspension in the ride, everything was understood by the automobile industry, and which was ably supported by the awareness we brought about the slip angle in cornering. Some of these are very technical terms. I'm sorry for that. I don't have the time to explain. And we also brought a lot of focus on the cornering force. The cornering force is the force which the tire develops as it takes a turn, and aligning moment. And awareness about the relaxation length was brought, which was quite useful for the automobile industry. Relaxation time length is the time taken by the tire to develop necessary cornering force while it takes a turn. And tire performance criteria were also identified. And in the current era, which is called electronic era, the automobile is controlled by electronic system, where the optimal tire response to input forces were identified and created accordingly. And tire performance tuned with the vehicle, and tire-vehicle interaction simulation are also in place. So you can see that evolution of automobile industry was ably supported by the evolution in the tire industry. So I don't want to dwell much on this because these are all quite known to everyone. There are very strong forces for technology changes because we are passing through a very disruptive phase of technological evolution. Looking at some of them, environment is creating a lot of, we are creating a lot of problem for the environment, and as a result we are seeing climate changes, and climate protection becomes a huge requirement for us. And economic side, we are seeing rising prices of fuel oils and shortage of resources, and population growth brings challenges for the sustainable mobility. And case is quite known for the automobile industry. And urbanization, if you look at urbanization trend, 61% of world population in cities will be in, the 61% of world population will be living in the cities by 2030, and which will create density for the traffic, and a lot of noise pollution will be there. And there are policies supporting technological changes or enforcing technology changes. So all these are drivers for the technology changes which we are witnessing today. And if you look at the value hierarchy of the emerging automobile market, there is a clear change happening. In the classic automobile market, you see the system supplies and component supplies at the bottom layers of the pyramid. Whereas in the emerging or future automotive market, you will see the electronics and system suppliers or component suppliers are coming on the top layers. And you have witnessed this. You have witnessed this during the pandemic period. A shortage of a small chip has created so much of disruption in the automobile manufacturing. So this is the emerging value chain or value hierarchy change. So all the evolution around this will be based on this change also. And the most important challenge we are facing today is electrification of the vehicle. You can see the electric vehicle market is going up exponentially. And this is also bringing a lot of challenges, particularly for the tire industry. And to name them, sustainability will call for lightweighting of the vehicles. Rolling resistance, of course, we are all talking about. Traction on wet and dry will be a challenge. Handling of the vehicle, load capability, NVH and ride comfort, aerodynamics, all will be the challenge for the automotive industry as well as for the tire industry. So I will touch upon some of them. And if you look at the characteristics of electric vehicles, and we normally believe the electric motor has got an instant torque, and they also have regenerative braking. So because of this, there is sudden high acceleration torque, which will cause slippages between the tire and the road. And the braking torque on the driving wheel also can cause slippages between the tire and the road. So the tire requirements will be high traction. The traction is the ability of the tire to hold the road under the torque without slippage. And when the tire holds onto the road with high torque, there can be wear. So wear resistance will be another requirement that has to be supported by the tire industry. And if you look at the noise pollution, the most noisy part of the vehicle is getting away, which is the engine. So the electric vehicles are much quieter. And next comes the contribution from the tire and road interface. So tire noise has to be very, very minimal to support the comfort part of the electric vehicle. So the tire requirements are low cavity noise and low pattern noise. These are the two sources of noise from the tires. So this has to be supported by the tire industry. And durability, you need, in order to match the efficiency of ICV engines, you need to have big and heavy battery packs. So that increases the whole tire weight. The tire requirements have to be changed accordingly from standard loading to extra loading to heavy loading. The load carrying capacity of the tire structure has to be improved. This will be another important requirement from the tire. Then the most famous range anxiety. So a tire, when it rolls, consumes a lot of energy, which we call as tire rolling resistance. And if we can minimize that without compromising the traction, I think that will lead to an enhancement of the range that we can derive from every charge of the vehicle. So these are generally the requirements that will be met by the tire industry to support electrification of the vehicles. And I am also trying to highlight two prominent technologies that will ably support the electrified vehicle, which is the foam technology and self-sealing technology. If you look at the noise, if you look at tire as a source of noise, there is one particular source of noise, which is the vibration of the air column inside the tire cavity, which is coming in the range of 200 to 250 hertz, which is very, very prominent for the in-cabin noise. In the case of an ICV, this particular range is masked by the engine noise. So when the engine is getting out of the vehicle, this noise will become very prominent inside the cabin. And reducing this noise becomes very important for the overall comfort enhancement of the electric vehicle. So there are technologies like laying polyurethane foams or some other materials inside the tire which can dampen this noise and which can significantly reduce. My own experience says almost 5 to 7 peak dBA can be reduced using these technologies. And another one is extended mobility support through self-sealing technology. So in India, in markets like India, what we face is the puncture. And this kind of laying of this kind of material inside the tire can effectively seal in the event of a puncture. This can help in extended mobility. And we can probably eliminate a spare tire, leaving the space for bigger batteries and enhanced range. And rolling resistance, the bigger question is how much we can reduce. If you look at the last 100 years, tire industry has reduced rolling resistance by almost 80%. And now we are asking for further reduction. And we are going from, this is what we call RRC, rolling resistance coefficients. Now we want to have somewhere around 3. So when we are entering in this range of rolling resistance using current technology, we are entering into a trade-off area. We may have to compromise. Tire has to be light-weighted. A lot of damping will be taken away from the tire structure. So that can lead to challenges in the NVH and comfort. And if you further go on, you may have to harden the tread compound, which has to envelop the road. So traction will be a compromise, mileage will be a compromise. So we are entering into a trade-off area. So how much you can reduce rolling resistance using the current technology is a bigger challenge in front of us. But there is some light in the end of the tunnel, because what we are seeing is EV proliferation. And we are also seeing drastic improvement in battery energy density. And today, almost 20% of the total energy is coming from renewable energy sources. So as we start getting more and more renewable energy from renewable energy sources, RR can no more be an issue. So this is a positive signal what we are seeing. So then we can concentrate more on safety aspect like traction. So what is tire traction? Ability of the tire to hold the ground without sliding under the torque. So primarily this is determined by the frictional forces generated by the tire and the road. And major factor limiting traction for EVs is the maximum tractive effort that tire and ground contact can support. And another major challenge in this aspect is the aging of the tire. You can see, I have shown a new tire and a worn tire surface. You can see a lot of cracks formed and the compound become hardened and it loses the damping capability. So there can be a compromise on traction. And a lot of suspended particulate matter can also emit during abrasion of the tire. So preservation of tire traction through entire tire life will be an area of research for tire industry. And reducing particulate matter emission from tires will be another area. And this is also going to be enforced by the upcoming regulation, Euro 7, and which will be enforced for cars and vans from 2025 and for heavy commercial vehicles by 2027. Our Honorable Minister of Road Transport also referenced this. We also have to be ready for this. So this proposal tackles emission from tailpipes as well as from brakes and tires. So now let me touch upon automobile vehicles, because if you look at the statistics, drivers are responsible for most of the accidents. So you take out the driver from the vehicle, that can be a solution. And here comes the role of the tire. As tire is the only link between the vehicle and the road, a lot of inputs have to come to the vehicle control system from the tire. So the tire has to become a lot of intelligent. Tire will have a lot of embedded sensors in that, measuring various parameters like forces, tread depth, age, mileage, tire loading history, and tire pressure and temperature, which are already there, what we call as TPMS. So sensors attached to tires will facilitate condition monitoring, performance enhancement, and safety maximization. So this will also enable new business models like instead of product selling, you can have service selling and pay as you go, fleet management, etc., etc. So this also moderate variations in the driving. And what is the change in tire requirements when you move into autonomous? So AV demand greater amount of reliability and durability from the tires. Today we talk about ride and comfort. As the vehicle control systems are taking care of that, more thrust will come on the reliability and durability of the tires. And somewhere I read that when vehicle is controlled by vehicle control systems, the tire life will also come down. I don't know whether it is true. In that case, early changes of tires will be required, which will also call for better tire recycling and more use of naturally occurring materials in the tires. So the underline is tire durability and reliability become key requirements along with the traction, but ride and handling will lose their dominances. So non-pneumatic tires could be another answer. This is already there in areas where high performance requirements are not there, like mining and agriculture, etc. Currently, the challenge for us is to create necessary training force when the tire takes a turn. So this is already there in areas where high performance is not there, but surely we can see in the future this will be in high performance areas also. Because air causes major variation in tire performance, so take out the air from the tire so that you can eliminate problems related to air pressure variations. So Apollo's initiatives towards business excellence. I will also touch upon current priorities, virtual development, sustainability support, and digitalization. And our priorities today are basically a total cost of ownership for the customer. The elements are mileage, rolling resistance, and durability. And comfort, safety, and sustainability. The elements for this part is noise, minimum noise from the tire, high traction from the tire, and usage of biomaterial and recyclable materials for manufacturing tires. And comfort and convenience. Extended mobility and tire sensors also offer convenience. And virtual submission of tire approvals, this is getting into place now. So from automobile side, we get vehicle characterization models. And from our side, we have special equipments to create characterization of the tires. And this can be combined virtually using vehicle multi-body dynamics software, using the prescribed test standard. And we can offer the target tire setting back to the OEMs. So we can work virtually, which we call as a virtual submission of tires for OEMs. So this is also happening in an effective way in our company. So Apollo Tyres has taken a sustainability goal to be carbon neutral by 2050. So various approaches are increasing the use of sustainable material in our products, using bio-based material and recycled materials, enhancing the tire longevity, increasing the mileage, improve retardability and retard quality, and rolling resistance reduction. Because when tire does less work for rolling, it will last more. And reducing the wastage of material and energy through lightweighting of the tires and reducing energy consumption in the manufacturing process itself. So our initiative towards Industry 4.0, I remember until a few years ago, I was using Excel spreadsheet for collecting the data and struggling with the data to take decisions. But today the scenario has changed. We did some first things first. We digitized information and we digitalized our processes and operations of a business, and we digitally transformed the business and its strategy. Historically, our IT managed business application from front office and operational technology kept a plan running. So bringing these two together, there are great advantages what we are seeing. One is the vertical visibility between the top floor and the shop floor, so the performance of the machines can be related to the business performance. And we could also eliminate unplanned downtime through predictive maintenance, and wireless gateways are deployed on factory shop floors. We could also ensure cyber security for new world of connected machines. And we are also digitalizing the entire value chain in business, and also bringing new business model like product selling to service selling, etc. So summary would be, automobile evolution it poses great challenges for the tire industry. And after rolling resistance, noise, tire traction and abrasion through usage life will be the focus areas. And add-on technologies, digitalization and sustainability will gain importance. That's it from me. Thank you so much for your listening.